All right. So what we're going to talk about now is the just basics of science. All right, this is the process in which we solve scientific problems. Just talking about what science is. Try to keep this relatively short and sweet. All right, so the goal of science is just to investigate and understand the natural world, to explain events in the natural world, to make use of those explanations, to make useful predictions. Um, and it's important to keep in mind, science only deals in the natural world. We're not going to talk about like anything supernatural or anything like that. We're not going to get into any of that. All right, so what we will be doing, though, is just doing things like collecting data, organizing data, carefully looking at it, see if we can observe patterns, experimentation, testing. I mean, that's all things that are basic parts of science. And it really all begins with an observation. All right, well, what is an observation? What you observe, what you can see, touch, smell, sense. All right, something that is being observed that leads to essentially a question. All right, and then you start to gather information about this process, and then that gathering of information is called data. All right, because I'm going to say that a lot. Some people call it data. I don't care what you call it. But when you were doing experiments, to say, hey, make sure you guys collect data, make sure you guys are collecting data, writing it down in your data tables, all right, just stuff that we see, all right. Now, data is just information that you gather when making your observations. Now, that can be either quantitative or qualitative. Now, quantitative data, that's just numbers, all right. It's a fancy way to say, hey, write down some numbers, all right. So, quantitative data, just the numbers obtained by counting. Qualitative data is a description, all right. It's a way to describe something that is being observed, not numerically. Like quantitative data would be like, I'm trying to see how high this ball will bounce when I drop it from a meter, and I'd measure how high it bounced. That would be my quantitative data because it's a number. I've used it by counting, measuring, etc. Qualitative data would be more of a descriptive term. Like what does the substance look like if I mix in hydrochloric acid? What happens to the substance? I would explain that. It fizzes, it bubbles. I would explain descriptive parts of it. So data can be either descriptive or numerical. All right. And so one of the things that we're going to be talking about is this scientific method, this process used to solve steps, to solve problems. First thing you have to do is you got to start with the problem. You've got to ask yourself a question. Make an observation, ask yourself a question. Now here it's going to say step 2 is gather information. Sometimes these two go hand in hand. All right, so later on I don't have this necessarily in 2. But obviously if you just have a question and you don't know anything about it, you might have to gather more information in order to form a hypothesis. All right, so if we look at it, this is step 1, just asking a question. It does not matter. This is something we're going to be doing here in a little bit, probably a week or so. I'm just going to have you guys, hey, come up with a problem you want to solve. All right, let's figure this out. Ask a question. What are we trying to solve here? All right, and we're always going to do this. How does one thing affect another? How is one thing affected by another thing? All right, so we're going to start with just asking a question. And like I said, if you need to gather more data, make sure you do that. And so then a hypothesis. Well, what is a hypothesis? Once again, it's a possible explanation to a question or a problem. It's a prediction. You can't get this wrong. I'm going to ask you guys throughout the course, hey, what is your hypothesis? Write down your hypothesis. And I always get kids that are like erasing, like, oh, crud, I got my hypothesis wrong. Doesn't matter. You're guessing anyway. Who cares? All right? I'm not going to be mad at you. Just guess. All right? So a hypothesis, if you're wrong, that's fine. There's really not wrong. It's just now I know that was not what I thought it would be. All right, and so you learn from that. All right, so if I ask you guys to, when we do our own experiments and all that stuff, when we do experiments, write a hypothesis. Don't go back and change it. Just at the end, your conclusion is my hypothesis was incorrect. That's okay. All right, that's not a big deal. All right, so don't freak out about that. It is simply a prediction, been proven or not proven. All right, it must be testable though. I mean, that's a huge part. All right, because if you're like, I want to know if this piece of cake smells good. I don't know why I used that. That was a weird example. But anyway, you can't just say something that's relevant. It has to be something that's testable. It has to be something that can be confirmed by other people if they tried to do the experiment. All right. So if it's like something like, is this good? Well, that's all relative to the person that's doing it. All right. Like I could think something's good, so you could think something's bad. It has to be something that can be, data can be collected. It has to be testable. It has to have evidence that supports or disproves it. All right, it can't be up to question. So whenever you're forming a hypothesis, make sure that's the key. All right, and I'm going to talk a lot about how that differs from a theory later on, because we always say, I have a theory about something, but we misuse the word theory a lot. All right. So that's going to be the next part. And then the next part, if you go back here, let me go to here, is going to be to design an experiment. Test your hypothesis. All right, so this is what I think would happen. Now I'm going to test it. I'm going to try it out. All right, designing an experiment. All right, I'm going to get into what an experiment is in a minute. All right, I'll get into what parts of an experiment are and all that stuff. I'm going to do that in the next video. All right, and so then I'm going to record and analyze my data. Make sure whenever we're doing an experiment, you have a data table. All right, and I'll talk about how to use a data table, but it should, at the very minimum, have variables that are in your experiment. All right, so it should, at the very minimum, have your independent variables. Same thing. I don't expect you guys to know necessarily what those are. I'm going to explain that more in the next video. All right, but make sure you record data. Make sure you're writing stuff down. It's better to write more stuff down than not enough, because if I say, well, what happened when you do this? You know, I don't know. All right, you're going to get that wrong. So make sure you have that written down. And then lastly, it's going to be drawing conclusions. Were you correct? Look at your data. Now, sometimes what we'll do is we'll look at data, we'll analyze it, we'll look at it, we'll graph it so you can see a trend, if a trend is occurring, if there's no visible trend. Based on the data we've collected in the tables, based on the graphs that we've had, we're going to draw conclusions. Is my hypothesis proven or disproven? And it must be repeated. If it's proven, it's got to be able to be repeated over and over again. All right, so when we do experiments, you're going to write your own procedures. We'll get to that point. You guys will write your own procedures. You need to be able to have somebody, if somebody just walked in off the street and you said, hey, do this experiment, they'd have to be able to follow your procedures step by step. They could come to the same conclusion you did. Then your hypothesis would be proven. All right, if they come to the same conclusion, if it withstands repeat testing, it will come true. And then a theory, then if a theory becomes formed after a hypothesis has been tested many times and is supported by much evidence. Like I said, we misuse the word theory a lot. We say, I have a theory as to why this is. What we should be saying is, I have a hypothesis. But hypothesis is just I have a hypothesis. It's just, I don't know, I think it's just harder to say maybe, I don't know. I'm not really sure why we do that, but we misuse the word theory when we use it. So every time in science class you come in and you say, oh, what's a theory? Everybody's like, it's a guess. It's not a guess. A theory is not a guess. A theory is not a guess. A theory, not a guess. All right? It's not a guess. A hypothesis is a guess. It's an educated guess. It's based on what you think would happen. A theory is a broad, comprehensive statement of what is thought to be true based on the evidence provided. All right. So when we talk about the difference between a hypothesis and a theory, because I will throw that question, that'll be a test question. What's the difference between a hypothesis and a theory? Hypothesis, educated guess. A theory is not. All right. So make sure we understand the difference between those. All right. Next video, we'll talk about the basics of a experiment.